Let's humble ourselves and we pray. Loving Heavenly Father, thank you for this day. Thank you for the gift of life and salvation and all you've done for us. As we're going for this mathematics lesson, we pray that you'll give us the wisdom and understanding to do everything well. We also pray that the connection will be good and that we shall go through everything perfectly. In Jesus' name I pray. Amen.
Amen. Thank you, Adeka.
Welcome.
Mr. Theo, are we picking up from the questions we ended at last week? Sorry.
Yes, we ended the class when they had many questions, and we felt that it's important we gave them an opportunity to ask whatever questions they are having concerning what they did in the test before we can start off another topic. So girls, we want to pick from where we stopped. I know some of us had many questions, and we don't want to go into something new before we can help you understand the concepts, because the test you did was covering almost what you've covered since you joined S1. Yeah, so can we start off by hearing from you? I see some hands up already.
Yeah, let's have Varia.
Teacher, there is this question called, in a class of 36 students, and three quarters of students are boys. Yes, something like that.
Maybe you can help project.
Okay. Let me try to. So is my screen visible?
Yes.
It is, eh? Okay.
Excuse me, teacher.
Yes, please.
Can I help on that number?
Yeah, sure. Let me try to get a question, and then you tell us how to do it. Yeah. I think this one. Yes.
Teacher, it says in a class of 36 students, 3/4 of the students are boys and a third of the girls wear glasses. How many girls do not wear glasses? So for me, what I did. Yeah, can you hear me?
Yes, we are hearing. Joseph, you try to mute those who are not.
Okay, for me, what I did. For me, what I did is I first got the number of boys. I said 3 out of 4 times the 36 students. Yeah, can you hear me?
Yes, what did you do?
I first wrote boys. I first got the number of boys, then I said boys equals 2. I can't actually see what is right, can I?
Okay, you got boys?
Yes. And then I said boys equals 2. 3 out of 4 times 36. Then I did.
What did you get as your answer?
I divided 4. Let me first use a calculator. 3.
No, you don't need to use a calculator. When you cancel 36 by 4, what do you
9.
get?
9.
Huh? Then by 4, 1. So what is
Yes.
3 9?
27.
So there are 27 boys.
Yeah, yes. So from here, and a third of the girls wear glasses. So I got the number of the girls in the class. Then I said,
How many girls are there?
36 minus 27.
You?
27. The girls are 9.
Okay.
Then I said girls that wear glasses. They are a third. So I said a third. Let me first wait.
A third of what?
A third time was 9.
A third times 9, which gave you?
I divided 9, divide by 3. I got 3.
Okay.
And then those are the girls that wear glasses. I then subtracted 9 minus 3 to get the girls that do not wear glasses. I got 6.
You got 6, eh?
Yes, the girls that do not wear glasses, I subtracted 9 minus 3, then giving me 6.
So the person who was asking, that is one way of doing it. I don't know if your friends are having any other idea. Martha, can you try to get other views?
Okay, can we have someone? Thank you, Shugi, for that presentation. Yes, Charity, you can go ahead and unmute.
Joseph.
Paul Hannah?
Joseph?
Yes, please. Yes,
now,
please.
I'm concentrating on the whiteboard. The girls who are not having streams, can you send them to the waiting room?
Yes, that's what I'm working on. Thank you.
Send them to the waiting room until when they behave. Eh?
Okay.
Okay, let's go on.
Vanessa, you can unmute.
Teacher, for me, I've just thought of another idea of how you can do this number. They say that 3/4 of the students are boys, so you can say 1 whole minus 3/4 to get like the fraction for girls. Then after getting the fraction for girls, you do the same thing. You say it will be a third. Then you say a third times. Will it be a third? Yeah, it will
Okay,
be.
Vanessa.
Yes.
Vanessa, how did you do it? You go through it again.
They said 3/4 of the students are boys. So you say 1 whole, meaning like the whole class minus 3/4. Then
Which
it's
gives
out.
you?
It's 4 minus 3 out of 4.
4 minus 3 out of 4, which gives you?
1/4.
So this 1/4 represents what?
The girls.
Represents the girls. So this is the fraction representing girls.
Yes. Then they said, and a third of the girls wear glasses. So I think you can say a third times 1/4, maybe.
A third times 1/4. So fraction of those who wear glasses. So you've said it's a third times?
1/4.
Which gives you?
1 out of 12.
1 out of 12. And then?
And then I think you multiply 1 out of 12 times 36.
Times 36. One out of 12 times 36, which gives you what?
3.
Gives you 3.
Yes.
These are the number of girls wearing glasses.
Yes.
So after that,
Then
stop
I
there
think,
because the question was asking how many do not wear glasses.
then I think you have to what? First find again the number of girls, then you subtract.
Because if you've got this as the number of girls that are wearing glasses, we do not know that of girls. So that means you'll go back and use that fraction. Is that what you're telling us?
Yes, because that's the way to find the number of girls, then you subtract.
Okay, let me ask. If you know the fraction for the number of girls that wear glasses, 1 out of 12, is it possible to get those that do not wear glasses using this fraction?
Yes, yes.
Yes?
Teacher, you are breaking. I didn't hear you.
Yeah, I'm saying if we know the fraction of the girls that wear glasses, can we get the fraction of those who do not wear glasses?
Yes, teacher, you just say a whole minus 1 out of 12.
Which gives us what?
It gives us 11 out of 12. Does it?
11 out of. So if we know that, can we get the number of girls that do not wear glasses using that?
No, teacher, you don't get that. You don't get the answer.
Okay, anyway, you've got the number that's wearing glasses, so you can use a quarter to determine total number of girls, and then after that, you can subtract and you get those who do not wear glasses. I'm seeing someone's up.
Yes, we have our default.
Yeah, for me, I have a question.
Okay, go ahead.
I have one of those questions, like once they gave me that test, I wanted to know that, like once I failed.
Our default, you have a different question?
Yes.
Yeah, let's first finish this, then you can ask.
Okay.
Okay, Martha, I don't know if this is clear to them. There are 2 ways.
Someone was
one,
asking,
yes.
Mr. Theo, I saw a question in the chat where someone is asking, why do we multiply a third times a quarter?
Vanessa, do you have an answer for that?
Yes, because like they said, a third of the girls wear glasses, and then we found a fraction for girls, which was a quarter. So you multiply a third times a quarter to find like the fraction for girls who wear glasses.
Okay, thank you. Do you have more questions?
I'm seeing 3 hands up. There is Charity.
Teacher, I just wanted to give another method where you first find the fraction of girls, which is a quarter. Then after that, you find the number of girls by multiplying a quarter times 36. Then you get a third times the number of girls that you've got. And those are the ones that wear gloves. that wear glasses to get those who don't wear glasses. That's all.
Okay. That's okay. I think we can all agree that there are many ways of going about this number. So you need to pick whichever way you find easier. Okay. So I don't know if this is clear to everyone, because I want us to move on to the next question.
I think it is.
Okay.
I think.
Can we?
Okay, let's hear from our Adifo. Adifo, what was your question?
I wanted to know, like, that part where they converted 1.34545 to a fraction. I think teacher explained it last week, but network was bad.
Which question?
Says convert 1.34545 to a fraction.
Converting, eh?
Yes.
I can help on that.
Then that what I think we did that question. We didn't understand it.
I didn't.
Do you have anyone who can help our DIFO understand?
Yes, teacher can help her.
Okay.
If it's theories, we knew.
Okay.
And in fact, this problem, you know, when we
Okay,
years started
Yes.
We first find the let the common fraction be x.
If someone is not contributing, please can you have your microphones muted so that you create a better running environment? So rate the common fraction
Bx.
Bx.
Then we say x.
Yes.
Recurring.
Equal to
1.34545 recurring. Since two numbers are being recurring, we say 100.
Yes.
100x equals 100 times 1.34545 recurring.
34545 recurring.
Then when we round up, like when we move the decimal point 2 steps, it gives us 134. 134.5454 recurring. Teacher, 545, not 45.
What do you get?
334.54, not 45. Point 5 for recurring.
5454 recurring.
Yes. Decimal point here. You missed the decimal point. Yes. And then we get 100x equals 100x equals 134.5454 recurring minus x equals 1.34545 recurring.
So you are saying we subtract?
Yes.
5454
recurring minus x equals
minus x.
Yes. Equals 1 point. Not there where the decimal point starts. Yes. 1.3454 recurring.
Which gives us?
Teacher, you remove the 5. Remove this previous 5. We have to stop where the first number ends.
We have to stop
from
where?
Here. You remove the 5, yes. Not all of it. We just remove the 5, the extra 5. We have to stop where the first number ends.
Okay.
Yes.
So we remove this.
Yeah, we remove it. And then when we subtract, we get 99. 99 x equals 133.2. Yes. Then, and since this part has a decimal point, we remove it, giving us 99 x equals 1,332 out of 10.
So we divide by 10 because of the decimal.
Yes, so we multiply the 10 on both sides. Yeah, then we multiply the 10 on both sides.
So we have 99 x
times 10.
That's why I don't encourage students to use x, because it confuses when you're multiplying. That's why it's always good to use a different letter.
Okay.
So we have 990 x
equals 1,332.
Okay.
And then after that, we divide the 990 on both sides.
Which is
giving us one remainder.
So this goes with that. Then
Yes.
x is what?
The answer is 1 remainder 342.
What answer do we get before we reach?
No, yes, that's the one. First you get 1 remainder 342, one whole number 342 out of 900. 42 out of 900.
990.
Yes, no, we divide by 3.
Is it? By 3?
Actually, let me first work it out because I don't remember the answer I got.
Okay. If you're having a calculator,
So it's 144.
One?
In view of the fact
One,
that we have
114. 114. 114. If
Then
it's
down
divided
here?
by 3.
Then 3?
And then down there it is it's 330.
Okay. So what do we get eventually? Is that the final? Can 114?
No, that's not the final. Then you divide them again by 3.
So what do you get?
114 by 3 gives you 38. And then you get 110.
Is that all?
No, we continue dividing. 38 divided by 2 gives us 19. And then 110 divided by 2 gives us 55, and that's our answer. Which is 19, not 17, 19.
This is 19.
Yes. That's our fraction.
So our default, I don't know if this makes sense.
It does.
Yeah, but of course there are other ways of doing it. Okay.
Excuse me, teacher.
Yes.
Teacher, for me, I'm confused. Right from this part of 100x is equal to 138.545 for recurring. Then here it changes. Okay, I'm confused from this part till the answer.
Okay.
Shall let
What
me
she
help
did-
her?
Uh-huh.
Okay, Gladys.
Yeah.
Like if it was one decimal point, like here, you could have said 10 times x to get 10x. But since there are two decimal places, there is saying then you say 100
Where?
times x. Like here on number one, there
These
is
numbers
3.
which are recorded
Yes, there are 2.
5 or 5.
So that's why
Okay.
they say 100x. But if it was 1, it would have said 10 times x.
Okay. Uh-huh.
And then that's when you begin from the way she began, like 100x. In my primary school, they used to say x here, like on the first x equals 1.345 recurring. You say equation 1. And then here,
That's right. Yes.
and then when you change it because of the two decimal places, you could say 100 times x equals 1.34, like that, equation 2. Then you subtract from there. So
You say
equation 1,
equation 2?
equation minus equation 1.
That's
And
true.
then you subtract, then you get what you got here.
Okay. I don't know if we are having other views before we move on. Yes.
I
Okay.
see. Glad.
I wanted to know, would you have multiplied that by, like, let's say 1,000? Why did you multiply it by 100 only? Why not 1,000?
Okay. As she has just explained, the numbers which are being recorded are 2. Okay. And because the numbers are 2, they are represented by the 2 zeros which are giving you 100. Eh? If it was one number being recorded, then you'd have 1 0. Maybe let me use that simple round. Yeah?
Okay, thank you.
The number of decimals or the number of digits recorded represent the number of zeros that you have when you're multiplying. Eh? Does it help? Anyway,
Yes, it does. Yes.
the easiest thing would have been to, if you read that.
Mami, kama jeba laptop yange ngambade ku Zoom.
Jose, can we mute those people who are disturbing us?
Yes, she was goddess, but I did so. Thank you.
Okay. Girls, I'm going to simplify it. We are finding it hard following the previous approach. So I'm rating YB equal to that decimal, or you can call it, let it be the common fraction. Some of you prefer putting it. Now, you realize that in this number, the numbers which are recorded are 4, 4, 5. Okay, so my first task is to first move this decimal to that point where the recurring is starting from. So what do we do? Multiply through by 10. Okay, multiply equation 1 by 10 so that the 10 can move the decimal once. Okay, 4, 5. 4, 5 recurring, which is going to give you 10y equal to 30.45 45 recurring. I'm going to call this one equation 2. Okay. Now I want you to note that the 10 was to help me move the decimal. I've not yet catered for the numbers which are being recurred. So how many numbers are recurring? There are 2 numbers. So I'm going to multiply equation 2 by 100 because there are 2 numbers which are being recurred. So when you get 100 times equation 2, which is 10y. You have 13.45 here. So this gives me 1000 y, and then the decimal is going to move twice. 1, 2. Okay, so I'll get 1, 3.
Excuse me, teacher, isn't it 1,000 that you're moving? Because 100 times 10 is 1,000. Oh, it's
I'm multiplying by 100. So 100 moves the decimal twice.
okay.
Yes?
Yes,
So
teacher.
when I multiply 100 times 13.4545, I'll get 13445. So I've moved my decimal from, it was near 3, it has moved to 5. So 45, remember 45 is being recurred. Okay, so you can write 4545 many times if you want. Now, as can we attend to the poll as we follow? Let's try to attend to that poll that is running on your screen. Okay, so we have 3 equations, but my interest is in the second equation and the third equation. Okay, so subtract equation 2 from equation 3. So when we subtract equation 2 from equation 3, you're going to have 1000 y is equal to 1345.4545. And then I'm subtracting equation 2, which is 10y. And I'm having 13.4545 recurring. And when you subtract this, 1000 minus 10 gives you 990. And you realize that this side, I'm having 1, 3, 3, 2. The 4 5s all collapse because you get 0. Okay, so this takes us to that expression we're getting after cross multiplying 10. Now, the reason why I multiplied by 10, it was to avoid a decimal when I subtract. You realize that in this previous work, when your friend subtracted here, she got a decimal here. Okay, however, if you know how to get rid of that decimal by dividing by 10, then you can still use this method. Or if you don't want the decimal in your subtraction, you can first multiply through by 10, because it was one number which was before the recurring digits. If there are 2 numbers before the recurring digits, you first multiply by 100. Okay, so this takes us to 99y equal to 1332. And when you divide through by 990, please attend to the poll as you listen in. We want to know how many people we are having this morning. So this one takes you to the same conclusion as what we got previously here, because you realize we had 1332 out of 99. When we simplified it, we eventually came up with 1 and 19 out of 55. So you follow the same procedure and then it should be able to take you to that answer. Okay? And once you've reached that answer, then you can conclude. Okay? Martha, I don't know if their hands, can you check?
Yes, we have Juwenji.
Teacher, what if there is no number before the recurring numbers?
Okay, if there is no number before the recurring numbers, then you form equation 1 and then you multiply through by the digits which are being recurred, and then you subtract straight out. In that case, you have two equations. So this second equation was basically to cater for the recurring number. If it's not there, you need maybe equation 1 and equation 3. You don't need 2. Yes?
A few. In the chat,
Yes,
we
please.
had some. I don't know if we can look at them.
Can I once again ask the girls to take the, I'm seeing 8 out of 50 in S1T have attended to the poll, 13 out of 50 in S1S, 18 out of 50 in S1K, and 11 out of 50. Can we take to the poll? Is it still on our screen? Girls?
It must be.
I read
Yes.
them. Can you attend to that poll first before we move on? Can you do that quickly? Joseph, can you run that poll again? Seems
Okay.
you run it again. Girls, I'm asking you to take the poll. Suppose we were interested in knowing who is who. Can we take it, please?
Excuse me, teacher.
Yes, please.
In working out how to find the fraction for the recurring number, does it always have to be 100 or it can go upwards?
It can go upwards depending on how many digits. If it's 1 digit, we multiply by 10. If there are 2, by 100. If there are 3, by 1,000. So we keep on like that. Depending on.
Teacher,
Yes.
I've worked out my own number and it was 1.344, but I got the answer as A equals to one whole number 51 out of 90. So if the number can't be divisible, I just leave it like the way it is. Because no number can divide both of them. So I just leave it the way it is.
I'm not sure I've got your question. Your network is static. Are you saying that if you are simplifying it, if you're having a fraction, yes?
Yeah, and I can't divide it like both numbers. So I just leave it the way it is.
It is okay. You only simplify it as far as it can be simplified. If it can't you leave it as it is.
Okay, thank you, teacher.
You're welcome. Okay.
Teacher, can you take it back?
I take it back.
The answer. Yes. No, not like that. Like the answer, you change it back to the decimal.
Yeah, they can ask you to convert a fraction to a decimal.
So
it is possible.
Divide.
Yeah, you're having one, so your interest will be in this. We use wrong division. We've done that in fractions and decimals. Okay,
Thank you.
Since we are having one whole number, our interest will be in that fraction. So we use wrong division, and the number we get, we shall have 1 point that number. Okay.
Teacher Steve.
Yes, please.
There was a question. Some girl wanted us to go through how we multiply bases.
Okay. Can we be?
We can first give someone a chance to take us through. Yes, I don't know whether they have gotten to that question. We can use the one which has multiply 534 base 7 by 123 base 7.
Can you repeat it?
Multiply 534 base 7. Okay. By 123 base 7.
Okay.
Excuse me, teacher, can I help her answer the question?
All right.
Yeah.
Since in bases, we know that the given base, the numbers in the given base don't go beyond that base. The principle in this question is that every answer we get must not be beyond 7. So when we get 7 times 4, we get 12. Since 12 is higher than 7, we get 7. Oh, sorry for stopping very fast. I'm going to be writing, I can just stay at the answer.
I'm hearing some noise in the background. I'm not sure I was following.
Teacher is saying is that since in bases, the numbers that are in the given base is not bigger than the number. The principle behind this is that every answer we get must be less than 7. So when we looking at our number, 4 times 3 giving us 12. 12 is bigger than 7. We get 12 divided by 7, giving us 1.
So
Yes,
12 is
7.
bigger. Yes.
Giving
So
us
we shall
1.
get 12 divided by 7, which gives us?
Giving us 1 remainder. Remainder 4.
Remainder 4.
Yes.
So where do we put the 4?
So we put the 4 down here and we carry the 1. We put the remainder in the answer area, we carry 1.
We put 4. Then we carry
1.
Take,
Yes. 3 times
then,
3. 3 times 3 is 9 plus 1 is 10. We get the 10 and divide it by the 7.
Me, teacher.
Teacher, I'm confused seriously now.
Teacher, 12 divided by 7 is 1 remainder 5, not 4.
Oh, sorry.
Yeah.
Sorry.
I'm following her. So when there is an issue, you can correct her. Okay.
Okay, sorry.
I was trying to do what she was telling me to do, so that okay. Anyway, this is the right thing. Yes. So 9 plus 1 gives you 10.
Yes.
So by 7, what do you get?
You get 1 remainder 3.
You get 1 remainder 3. So where do you take the 1?
You carry the 1 there. Yeah. And then when you, 5 times 3 is 15. And then 15 plus 1 is 16.
Then?
And then when you get 16 divided by 7, 16, yeah, 16 not 15. 16 divided by 7, we get 2.
Yes.
Remainder 2. So we write
2
the 2
remainder
there.
2.
Yes. Then we write, after writing the remainder, we add the 2 there. Since there's
So that 2 is
nothing
supposed to go somewhere there, which gives us a 2 here.
2. Yes.
Then?
And then we go to the next number. 2 times 4 is 8. 8 divided by 7 is 1 remainder 1. So we write 1 and we carry the 1. We write the remainder and we carry
Where
the
do we write 1? Under 5?
Under 3. And then we carry the remainder, we carry the whole number 1, 2, 3 up here. We carry it.
Okay.
Then when we get 3 times 2 is 6. 6 plus 1 is 7. 7 divided by 7 equals 1 remainder 0. We write the remainder 0 under 2 and we carry the 1 to 5. 5 times 2.
Yes.
5 times 2 is 10 plus 1 is 11. There we get 1 remainder. 7, 8, 9, 10, 11. Oh, we get 4. The remainder is 4.
And then?
1. Yes. Then we go to the next number 1. 4 times 1 is 4. We write 4 since it's less than 7. Under 0.
Where do we put it?
We put it under 0. 1 times 3 equals 3. We put it under 2. Under 4.
You put it under 4?
Under 4, yes. And then 1 times 5 equals 5 since it's less than 7. We put it there.
What do we do after?
We add 5, but making sure that the answers we get, they're not above 7.
Okay.
So 5 plus 0, 5.
So this goes down.
Yes.
So 5.
Okay. Yeah, it's 5. 3 plus 1 is 4. Then 4 plus 2 is 6. Yes, right, 6 now. Then 4, 5, 6, 7, 8, 9. 9 is bigger than 7, so we get 9 divided by 7. Giving us
So when you
1.
add 2 plus 4 plus 3, it is 9. 9 is bigger than 7.
So we get 9 divided by 7, giving us 1 remainder 2.
So you write 2. You
And
carry
the 1. Yes. So 5 plus 1 plus 1 equals 5, 6, 7. 7 divided by 7 equals 1, remainder 0. So we write the 0 and then we put the 1. There's 7. That's our answer.
Martha, I don't know if there are more ideas.
Yes. Yes.
Yes.
Mr. Theo.
Yes, Martha.
Teacher Theo.
Yes.
Yes. I'm sorry, my network has disturbed me a lot, but there is something I had wanted to comment on the other number, the previous number, but maybe it will come in later. But for this one, okay, here they are free to multiply. Let's first finish up this one, then maybe we shall go back that one later. For this one, this is a shorter way of doing it, but they could as well change. Of course, when you change this number to base 10, you can change both of the numbers to base 10. Then multiply normally, and your final answer can also be converted back to base 7. So that's another way of handling that. So, yes.
Thank you, Teacher Jennifer. Yes. If
the powers, don't forget the powers, okay?
If you're not comfortable with that method, you can convert the numbers to the standard base, which is 10. Okay. And the values you get, you can multiply them normally and the answer you get, you convert it back to the base that the question is asking you to have the answer in. Okay. So can I get these answers? Did anyone do it this way?
Yes, teacher.
What is the first
245. The first
200.
answer is 245
And
plus 21 plus 21 plus 4.
Which gives you?
And you get your answer as 270. 270.
But this is base 10, eh? Don't forget.
Yes.
Then can we convert
Then we
the
also change
next number?
7, which is 1 times 7 to the power 2 plus 2 times 7 to the power 1 plus 3 times 7 to the power 0.
Okay. Which gives us?
1 times 49 plus.
So this is 49.
2 times 7 plus 2 times 1.
This is 14. Which is?
That is 21.
What do you get?
3, yeah.
What do you get as your answer?
I get 66.
66 to base 10. Okay. So we are having 66 to base 10. And, it implies that you are going to get 270 times 66. Eh? Yes.
Yes.
Okay. Let's go this side and we multiply normally. 270 times 66. We multiply normally. What do you get?
6 times 0 is 0. Then 6 times 7 is 42. So you write 2 and carry 4 to 2. Then 6 times 2 is 12 plus 2, which is. Shall I writing? So 6 times 7 is 42. You write 2, then you carry 4.
Okay. 6 times 0 is 0. Then 6 times 7 is 42. What do you write?
2, then you carry. You write 2, then you carry 4. Then 6 times 2 is 12 plus 4, which is 16. So you write 16 there. Then 16 times 0 is 0, but you write the 0 under 2. And 6 times 7 is 42. You write 2, you carry 4. Then 6
So
times 2 is 12, 16.
Yes. Of this.
Then you get 0 plus nothing is 0. Then 2 plus 0 is 2. Then 6 plus 2 is 8. 6 plus 1 is 7. Then they are 1. Then after we change
this is base 10. Okay.
Yes.
Oh.
Yes.
When you are changing, what do we do?
You write the number you draw 3 columns. Yeah. Then you write the number in the middle, then the base on the left, then on the right, you have the remainder.
Okay.
So the number is 17,820, and we are changing it to base 7. So you divide it by 7.
What do you get there?
And you get 2545, remainder 5.
You get?
2545, remainder 5.
Remainder 5.
5. Yes. Then 2545 divided by 7, you get 363, remainder 4. Then 363 divided by 7, you get 51, remainder 6. Then 51 divided by 7, get 7, remainder 2. Then 7 divided by 7, you get 1, remainder 0.
Then what do you do after?
Then for us, our teacher told us at school that you divide 1 by 7 to get 0, remainder 1. Then after you take the side of the remainders only. But you can also stop there, then start from the last number in the column of n up to remainder. Yeah, like that. And you get the answers 102645 base 7.
What were we multiplying? Can someone remind me? Base 7?
543 base 7 times 123 base 7.
543 base 7
times 123 base 7.
123
equals 102645 base 7.
102.
Teacher.
Yes.
But now where does this number of 270 times 66 come from?
Okay.
We changed 543 base 7 to base 10 and 123 base 7 to base 10. Then we multiplied normally. Then we changed our answer back to base 7.
Oh, it's another working. Okay, that makes sense now. Thank you.
So we have two approaches here. Okay. So whichever approach you find easier, you go for that. The first approach is multiplying directly and you leave the numbers in the base. But you have to bear in mind that what you get should not go beyond the stated base. Then the next is converting the numbers to the standard base, which is 10. And then the answer you get, you take it back to the base in the question. Okay?
Excuse me, teacher.
Yes.
And the method of changing the bases to base 10 also works for subtraction of bases.
Yeah, it works for all. It works, but you know, addition and subtraction are usually easy. Sometimes people don't waste time converting to base 10, but you can as well convert to base 10 if you are not comfortable. It can still come out.
What about division?
The same applies to division. Actually, with division, you cannot do the numbers without first converting them to base 10. Okay.
Yeah.
Yeah, with division, you have to first take them to base 10 before you divide. It's very hard to divide them in their respective bases. It's a bit complex. Okay, over to you.
There are some hands up, and yet our time is almost done. But we can, I think, hear from one. Namlindwa.
Can you hear from Marissa?
Namlindwa.
So I just wanted to ask about division of bases.
Division of bases. Girls,
yes.
I don't know why we seem not to attend to this. Well, Mr. Kijambo.
Excuse me, teacher.
Yes.
Question.
Yes.
And if during an exam they give me the same particular like kind of a number like that, I have to solve it. Which is the most accurate method should I do?
I'm not getting your question. Can you ask again?
This number you're just from doing up this one of 270 and
okay.
66 number you've calculated. You have done like two methods. Which is
yes.
the most accurate? Which is the most accurate method should I use? Both of them.
The method to use will depend on what you find easier. Some people prefer the first method if they know what they are doing. Okay. But others think that multiplying and you keep remembering to have the numbers not going beyond the stated base is a bit cumbersome. So they prefer converting the numbers and then they work out the numbers normally and then take back the output to the stated base. So it's a choice one has to make. However, if you practice, the first method is shorter and quicker.
Excuse me, teacher.
Yes.
What is quaternary base? Quaternary, yes, something of that kind. It was in the test. I
Someone to
failed it
help?
actually.
Yes.
It must be base 4.
Does it help?
Sorry, means fourth. So it's the fourth place.
Does it help?
Teacher.
Yes.
I put the digits that are in base 4 and they marked me wrong.
You put the what?
So, I put the digits that are in base 4 and then they marked me wrong, saying it's wrong.
Let me check the question you are asking. Might be mixed up issues.
Excuse me, teacher.
Are you talking of this quinary base or quaternary?
No, quaternary.
Shugi.
Yes.
Was the 4 in your answer? Because numbers
No.
in base 4 are 0, 1, 2, 3.
And
yes, there was no 4 in my answer.
But
There
was there
no
a 0?
for
Yes, there was a 0.
Is it quaternary?
Yeah.
Maybe you made a mistake somewhere.
No,
The
I
numerals
didn't make a
representing
mistake.
quaternary base is base 4. So
yes.
0, 1, 2, 3.
Yeah.
That's the
And then where did I make the mistake if I put that as an answer?
no, I think you did that number before. We had forgotten to tick off the right answer. So there was no correct answer actually for that number until we saw the mistake. But we corrected it. All those who had ticked it correctly, the system marked them right. So the system marked you right. Yeah, it marked. You're welcome. I guess I don't know if you're having more questions. Time is up.
Ario, Esther. Ether. Ario, Ether.
Yes. Teacher Martha, do you have more questions or we end the session?
There is Ario, but she can't speak. Nanyanzi, Hosanna.
I'm sorry, teacher. I thought I left my hand up. Let me put it.
What about Charity Kahuga?
Teacher.
Yes. Yes.
Yes. Teacher.
Charity, can you go on? Okay.
I think she's lost.
Since we can't get through to that. Can we hear from Marissa Namurinwa? Marissa?
Yes, I just wanted to ask about division of bases.
About?
Division of bases. Yes.
Division of bases, yes, I said it's easier to convert the numbers to base 10 and then you divide normally. The answer you get is what you take back to the base in the question.
Oh, yeah. Okay. Thank you. Thank you.
Okay. I guess that's it for now. We'll Gladys, yes.
Teacher, the work, this general math assignment that you gave, we are handing it in or we are writing it in our books?
No, it's supposed to be in your books because you already did the test. So you can't hand it in when you already did it online.
Okay.
That was your records.
Okay.
Yes. Charity. Charity. Kahuga, can we hear from? Okay, teacher Jennifer, teacher Joseph and Teacher Martha, thank you so much. I guess that's it. That's it for now. We'll see you next week.
Okay, thank you.
Bye.
Bye.
Thank you for the lecture.
Bye.
Bye. Bye.
teacher.
Bye. Bye.
Hosanna.
Bye, teacher.
Bye.
Bye, teacher.